All right, section 2.2, we dive into interpreting scatter plots a little more. The question we're going to try to answer today is, how do I describe a scatter plot? So we made scatter plots yesterday and we talked about them a little bit. We go into more detail today. So how do I interpret scatter plot? You look for patterns that reveal strength, direction, and form. And we're going to talk about what each of those mean as we go forward. So how strong is it? What direction is it going? And what's the form of the scatter plot? So strength, it's either strong or weak. Obviously, it can be like very strong or very weak or moderately strong and moderately weak. We use strong or weak to describe the scatter plot. The direction, it can have a negative association, which is when there is an indirect relationship between the two variables, which means when one variable is high, the other one is low. And then it can have a positive association, which would be when one variable goes up, the other variable goes up as well. So one example I can think of for a negative association would be like the number of questions you got wrong compared to the score you got in your test. So the more questions you got wrong, the lower your score would go. So if that one number goes up, the other one goes down. Or if you have a really high score in your test, the number you got wrong is really low. And positive association would be like the gas in your tank compared to how many miles you can drive. So the more gas you have, the more miles you can drive, the less gas, the less miles. So that'll be a positive association. Okay, the form, it can be a line, which is linear. It might be curved, and it might be clustered. So an example 1, identify the data sets as having a positive, a negative, or no linear relationship. So the number of hours a person has worked and the amount of money they've made. So as the hours goes up, is the money going to go up or down? So as hours go up, money goes up. So this is positive. Part B, the points a player scores during a basketball game and the score they got on their driver's test that day. Is that going to be a positive, negative, or no relationship? Do the points you score in a game really determine your driver's test? No. So this one is no linear relationship. And then C, the miles driven and the gas left in the tank. So we actually just kind of talked about this. As the miles you drive, the miles driven goes up. Is the gas going to go up or the gas going to go down? So as the miles go up, so the more you drive, the gas that's left in the tank is going to come down. So this would be a negative relationship. Okay, so positive, no relationship, and negative. All right, looking back at our example about ice cream sales and temperature, we would interpret the scatter plot as, so this is from the last page. If you flip back in the notes to 2.1, where we make a scatter plot for temperature compared to the amount of ice cream sold, the ice cream sales. As temperature went up, so did the ice cream sales. More people bought ice cream. So we would describe this as positive. And if you remember, it was pretty strong. They were all like close together. So we would say it is actually a strong positive relationship. Okay, example 2, we have some pictures. Interpret the following scatter plots, then write a sentence explaining what that means in the context of the problem, if possible. So if you look at the first one, you see how the dots are kind of randomly all over. There's really no connection at all. So this one has no relationship. There's no connection, like not really clustered together. There's no line formed. It's just nothing. The second one, if you notice, this kind of, these X's or these dots in the scatter plot kind of form a pattern there. So as we go, the Y comes down as the X goes over to the right. So as the X gets bigger, as it goes to the right, the Y value gets smaller. So this would be negative. And notice how close together those dots are. If they're really close, it's going to be a strong relation. So it's strong, negative, and it's curved. Strong, negative, curved relationship between X and Y. So how strong is it? Is it positive or negative? Is it curved, clustered, or linear? And then we got 2 more. So if you look at the one on the bottom left, do you see the form of this one? You see how they're kind of clustered here, and then they're clustered up here. So this one, I would give you 2 options. You could say this is clustered, or you could say it's linear because it does form a line. They aren't really close together, but they're also not like spread out really far. So I would say this is relatively strong. And notice it goes up. As the petal length goes up, the petal width goes up. See how it's going up from left to right? So how we would describe this, we would say it's a relatively strong, positive, linear. I'm going to put clustered next to it in parentheses. Because if you said clustered, I'd be okay with that. You could say linear or clustered relationship between petal length and petal width. So you could write that actually. There's another way you could say it actually, which might be a little better. This is fine. So if you have this written down, that's great. Or what I might do is you could actually cross out this. And another way we could say this, we could say relatively strong, positive, linear relationship between petal length and petal width. And then at the end, just say with clustering. That just means that the scatters are kind of clustered together. So that might be the best way to say it. All right, and the next one, do you see how there is sort of a relationship here? See how they kind of are grouped together a little bit? They kind of form that curve, but it's not like really close like the one above it. The one above is like really tight together, and this one's not. And it says % fat and versus BMI. So what we would say is it's weak. This is weak, relatively weak. And it's positive. Positive because it goes up from left to right. So it's relatively weak, positive, slightly curved. It's not quite linear. It's not a huge curve, but it's a slightly curved relationship between BMI and percent fat. Right, and that's what we got, just describing the scatter plot. Look for strength, look for shape, positive, negative, or no relationship. That's what we're looking for.